Uh, so far, we have completed module 1. Okay. Now, from here onwards, you will find little bit derivations and as well the problems based on the formulas. Okay. So let's move on to the module 3, that is the design of transformers. Okay. So till now, I don't know whether you're carrying a notebook or not, but from here onwards, please carry the notebook because you'll find a lot of derivations. Okay. And prefer one notebook for EMD only. Okay. And here also I'll be giving you a list of formulas that should be written on the backside of the book, okay, as what you were following in the TG. Okay. So in the design of a transformers, this is a syllabus part which we are going we need to cover it up.
ಸ್ಟಕ್ ಆಗ್ತಿದೆ
So
ಮ್ಯಾಮ್.
in today's class, I'm going to concentrate onto the output equations and three one topic, that is output equations of single. I'm audible.
ಎಸ್ ಮ್ಯಾಮ್, ಇವಾಗ ಕೇಳಿಸ್ತಿದೆ.
Okay. So now today class we will look on to the output equation of single phase and three phase transformers. Okay. Let's move on to that. So the other part and all we will cover it up in the few more classes. Before I start with the output equation, okay, of a single phase transformer and the three phase transformer, I would like to share this picture which already you are aware of it. First, we will think about the single phase transformer. Okay, so can you see that a single phase transformer, core type and shell type?
ಎಸ್ ಮ್ಯಾಮ್.
Yes. So here already you have studied a basic thing in this case. That is the. Can you hear now? Is it audible
Yes,
now?
ma'am.
Okay. This transformer, you can see that it will be. Okay. It will be consisting of limbs. So this we call it as a limb part. Okay. And this part, that is a horizontal portion of a yoke, is called to be as a yoke. Horizontal portion of a core is called as a yoke, and a vertical portion of a core is called as a limbs. Okay, so make sure that here you will find this as a one window. So there will be a one window. Okay, and whereas in the case of a shell type, when you prefer, there is a two windows, one here and the another here. What is the difference here? You will find is on a single limb, okay, one primary winding will be wanted. On another single limb, the secondary winding will be wanted. That is one observation which you need to consider when you're going to derive the output equation of a transformer. Similarly, here for the shell type, you will find that in a one limb there will be both primary as well as a secondary windings, okay, which will be wanted. Okay, so this is about the core type as well as a shell type. So here you will find what is the basic thing which you need to consider. So in this slide you have considered that what you mean by window. Window means the part where you will find it is going to form just like a square, okay, square manner, where you will find primary winding is founded and secondary winding is founded. Okay, Okay, so this forms one window. Similarly, in the shell type, this forms a two windows. Okay, so there will be two windows. Okay, now let's move on to the formulas, basic formula which you need to consider when you're going to derive the output equation. Usually, the output equation will be expressed in terms of kVA, kilovolt ampere. What do you mean by this? Kilovolt ampere. Kilovolt ampere means it is a product of voltage and current. Since the name indicates the output of a transformer is expressed in kilovolt ampere, so it indicates it is a product of voltage and current. Kilo means 10 power of 3. Okay, so let us move on to this basic formula. All of you take down. This is a prerequisite to derive the output equation. So if you are aware of this, you can derive the equation for around 6 marks. Okay, what is that equation? This equation already you have learned in the basic and in a transformer generator subject. So what is the EMF? E1 is equal to 4.44 F into psi m into N1. Can anybody tell me what is E1? Capital E1. What is capital E1? Capital.
EMF.
Huh. What is capital E1? EMF. Okay. EMF induced where? This is suffix 1 indicates what?
Primary.
Suffix 1 indicates what?
Primary.
Primary or secondary? Primary. Okay. So in so far in the lower semester, you have indicated suffix as 1. Okay. And what is N? Capital
Number
N.
of turns of a
N1.
coil. Number of turns.
What is capital N1?
Primary.
What is psi m?
Flux, ma'am.
Psi m. Maximum flux. Okay. F, I hope all of you know. Frequency. Okay, now fine. So here, this is a lower semester you have studied. Now, for a higher semester, this semester, what you will denote for capital N1 as a, this is a number of turns in the primary, will be considered as a TP. TP means P is suffix, okay, small letter. You can put it down, TP. So this is a number of primary turns. N1 will be substituted as a TP in this semester. Okay, so that is your number of primary turns. One at the same meaning. Okay, number of primary turns. So this notation you have to use. Okay, from now onwards. Okay, take it down. So therefore the equation becomes EP means primary. EP is equal to 4.44 F into psi m into TP. Okay, so this is first thing. Second thing is, again I will modify this. Okay, so what I will modify the formula is, this is a EMF induced in the primary, but if I want the EMF per turn, so that means E1 divided by N1. What is the formula? It becomes 4.44 F into psi m. Okay, so therefore that we call it as EMF per turn. So this T is small letter, okay, suffix ET, E small t, okay, it is suffix downwards, right? Okay, ET means it is a EMF per turn. In bracket you write EMF per turn. EMF per turn means EMF divided by turns. EMF per turn means EMF divided by turns. So this basic thing you should be aware of it. Okay, so this is about your the first basic thing. Okay, second thing is, what is a flux? How do you get this formula? Psi m. Okay, if you know flux density, what is capital B? Flux density. So that is maximum flux density. B, M is suffix again. It is small. Okay. So BM is equal to flux psi m divided by area. So that area current divided by area. Anybody can guess? Current divided by area. It is a current density. Okay, current divided by area means it is a current density. Current density is denoted as delta. All of you take down delta. Current density is delta, which is given by current divided by area. Okay, so that formula you should remember. Then one more from here onwards, it is all new thing. Only two formulas will be new for you. Two and this one, three. These are all the basic thing which already you have come across. Okay. Now, one more thing which are relevant, I'll just discuss it off. Well, what do you know? KVA. KVA is equal to product of volt into current. So volt ampere into 10 power of minus 3. Since this is a expressed in KVA, so you have to write it as VI into 10 power of minus 3. Okay, so that is a Q. So Q is a output of the transformer. Then this V, whatever is there, that will be denoted as EMF induced capital E. Okay, so that can be replaced as E into I into 10 power of minus 3. If suppose you want for the primary, so it is VP into IP, and this becomes EP into IP. Okay, for suffix and all, you have to take care from now onwards. Need not to write 1, 2 like that. Suffix, if it is primary, means P. Secondary means yes. Secondary means yes. Okay, so we have discussed the first formula. That new formula is ET, that is EMF per turn, is given by EMF divided by turns. And the another formula which is left out here, the new formula, which what is this? KW. KW is called as window space factor. KW is called as window space factor. What is this window space factor is? It is defined as the ratio of the ratio of area
Ma'am, voice break ಆಗ್ತಿದೆ ಮ್ಯಾಮ್.
area of a copper, that is AC, area of a copper divided by window area. Area of a copper divided by window area. Okay. Window space factor break ಆಗ್ತೀಯಾ? Okay. Window space factor is defined as area of a copper divided by the window area. Okay, area of a copper divided by the window area. What is area of a copper? It is nothing but the total copper area of the winding. It is a total copper area of the winding, which is given by product of turns T into area, small a. Okay, so here total copper area of the winding can be given as product of turns multiplied by A, that is small a area. Okay, that area will be, it can be, if it is primary means AP, if it is secondary means AS. So area of conductor of 2A. Okay, so that is a new thing which you have come across with this slide. So this is KW is called as window space factor. All of you can take down. Window space factor is defined as area of a copper is equal to AC by AW. What is AC? AC divided by AW. Make sure that
Area
it
of
is
current.
AW and KW. Whenever you cross multiply, the suffix should be W. That's all. Okay. On the numerator part, it should be AC. Area of copper. Copper. AC ಅಂದ್ರೆ area of copper. ಇದು area of window. Window. Window I have shown no, in the previous slide. That is area of the window. Copied till here. Only till here you copy. Till here. Don't copy this down, these two formula. Copy only till here. Done? Copy
Yes, ma'am.
till here. Okay. Now,
Yes, ma'am.
don't copy these two. Now, we are going to derive the output equation for single phase transformer. The final answer I have written here. This is the final answer for the output equation of single phase transformer. It seems to be Q is equal to 2.22 FBM into delta into KW into AW. I told you KW, AW should be together. So that value will be equal to AC. Okay. Like that you have to remember. R is, if you remember, like a class work. So first comes class, then work. So AC divided by AW. Like that also you can remember. Okay. Sometimes students will do ulta, the ratio. So remember as a class work. So it is AC divided by AW. Okay. So that is a technique how to remember. So KW into AW into AI into 10 power of minus 3 kV. So this is my aim, which I need to prove for the single phase transformer output equation. This is the final answer for the output equation of single phase transformer. Then for the three phase transformer, this is the output equation. Can you identify what is the change between this and this? Anything that's different
Density
from
is
single phase
missing.
and to three phase?
Density 3.33.
Density will be there. Okay, sorry, it is not printed here. It is there. Density is there. All of you can insert. Then anything else?
3.33 and 2.22.
Anything else which is different?
Oh, frequency, F.
That's all. Okay. So actually all these parameters, if is there, everything will be there. All the parameters by delta is missing here, but it is there. Okay. Only the factor it is going to change by 3.3. If you remember this formula, easily you can write for the three phase. Same parameter will appear, only the 2.22 will get changed to 3.33. Okay, done? Fine. Now, how to remember this formula? That is, as you all know, E is equal to 4.44 F into BM in psi m can be written as BM into AI. Do you agree with this? Psi m can be written as flux density into area. Okay, now, so if you express in that way, it will become 4.44 F into psi m into BM into, F into BM into AI. Okay, similarly here, you have to remember Q is equal to 2.22 F into BM into AI into KW that is together, this ratio. Okay, KW into delta into 10 power of minus 3. So that is your first formula of this module which you need to remember. These are all just a basic thing. Okay. Now let's move on to the derivation part. Take down the heading output equation of single phase and three phase transformers. Take down the heading. Done. Next, you need to define some parameters. Okay, because what is the actual formula? The output equation is 2.22 F into Bm into delta into Kw Aw Ai. What do you mean by F? What do you mean by Bm? What do you mean by delta? What do you mean by Kw? What do you mean by Aw Ai andre ಏನು? So all these things you need to define. Okay. So what I will do here, you don't take down, just you observe. Okay. This part you can take it down later after deriving it. Okay. So don't waste time here only. All of you. Okay. So the thing is already we have discussed what is Psi-m. Psi-m under main flux. What is Bm? Maximum flux density. What is delta? Current density. Current by area. So the unit becomes ampere per meter square. What is AGI? Andre idu gross area core. Andre we will measure only core area, the gross, overall gross. Okay, so that is a gross area, core area. Then what is AIN? AI means net core area or net iron area. Okay. Then what is AC? AC is area of copper. As I told, what is AW? AW is window area. What is KW? Window space factor. These are all the things now only don't mug up. You just remember the final output equation. From that you tell all this. What do you mean by F? What do you mean by psi? What do you mean by BM? Delta, AC andre ಏನು? AW andre ಏನು? All that thing you have to just list out. What is F? What is KW? Window space factor. And in addition to this, we need to define all this. As a transformer, you all know, no? Primary and secondary. Like that, in the primary and secondary, what all the parameters will come? Number of turns in the primary, number of turns in the secondary. What is the notation? TP and TS. Similarly, for the current, current in the primary, current in the secondary. That is IP and IS. Okay. Similarly, voltage, terminal voltage. Voltage in the primary was V1, which you studied V1. Secondary, you studied it as V2. But here in this course, you are going to utilize VP and VS. Primary ge P, secondary ge S. Okay, VP and VS. What is AP? That is a area of a conductor of the primary winding. What is AS? Area of a conductor of the secondary winding. So idella definition, you leave a space, then you start up directly with a derivation actually. Okay. What is actually the derivation? How you have to start up? This is a single phase transformer. Okay, before I go with the step by step, okay, I want to ask you some analysis. What is that analysis is? First thing what you will do, how to write down the output equation of single phase transformer. See, all of you just observe, don't write. Okay, output equation of a single phase transformer, it will be expressed in kVA. You know that. What did I told you the basic formula? ಈಗ prerequisite ಬರ್ದಿದ್ದೀರಾ formula, all of you. Prerequisite formula. ಅಲ್ಲಿ what you have written for Q? Q, what you have written? For Q, what you have written the formula?
V into I 1
Product of V into I into 10 power of minus 3. V into I into 10 to the power of minus 3. Okay, now when you take up primary winding, so primary voltage, primary current, you have to just denote the suffix. Then what I told you, whatever the voltage VP is there, the same EMF will be induced. So that is, we are considering both the voltages as equal. This is for ideal case, you all know that. Okay, so V is equal to E. So that is EP into IP into 10 power of minus 3. Anta baritira starting. After that, what you will write here, this is the EMF at the primary. What is go to your prerequisite formula. In that first formula dalli ಏನು ಬರ್ತಿದ್ದೀರಾ? ಏನು ಬರ್ತಿದ್ದೀರಾ? EMF equation ಬರ್ತಿದ್ದೀರಾ? You have written the EMF equation of a transformer. What is that? 4.44 F into Psi m into N1. N1 is changed to TP ಅಂದ್ರೆ ನಂಬರ್ ಆಫ್ ಪ್ರೈಮರಿ ಟರ್ನ್ಸ್ ಆಯ್ತು. ಅಲ್ಲಿಗೆ ಏನಾಯ್ತು 4.44 ಎಫ್ ಇಂಟು ಸೈ ಎಮ್ ಇಂಟು ಟಿ ಆಗುತ್ತೆ. ಟಿ ಆಗುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಈಕ್ವೇಟೆಡ್ ಟು ಇಪಿ. ಓಕೆನಾ? ಯು ಆಲ್ ಆಫ್ ಯು ಡೋಂಟ್ ರೈಟ್ ಎನಿಥಿಂಗ್ ನೌ. ಯು ಜಸ್ಟ್ ಕಾನ್ಸಂಟ್ರೇಟ್ ಆನ್ ಟು ದ ಪ್ರೀರಿಕ್ವೆಸ್ಟಿ ಫಾರ್ಮುಲಾ ಅಂಡ್ ಲಿಸನ್ ಟು ಮಿ. ಓಕೆ, ದಟ್ಸ್ ಆಲ್. ಇವಾಗ ಅಲ್ಲೇನ್ ಬಂತು? ಇಪಿ ಇಸ್ ಇಕ್ವಲ್ ಟು 4.44 ಎಫ್ ಇಂಟು ಸೈ ಎಮ್ ಇಂಟು ಟಿಪಿ. ಆಯ್ತಾ? ಇವಾಗ ಇಪಿ ಡಿವೈಡೆಡ್ ಬೈ ಟಿಪಿ ವಿಲ್ ಗಿವ್ ಯು ವಾಟ್ ಈಸ್ ಇಪಿ? EMF. What is TP? Turns. So EMF per turn is denoted as ET. ET andre EMF per turn. So what we will do is this can be written as EP can be written as ET into TP. ಆಯ್ತಾ? ಸೊ ಇದು ಸಿಂಗಲ್ ಫಾರ್ಮುಲಾನ ನಾನು ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಹೇಗ್ ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂದ್ರೆ ಇಟ್ ಈಸ್ ಅ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಇಟಿ ಇಂಟು ಟಿಪಿ. ಇದು IP ಹಾಗೆ ಇರುತ್ತೆ. ಓನ್ಲಿ ಐ ಆಮ್ ಸ್ಪ್ಲಿಟಿಂಗ್ ಅಪ್ ದ ಫಸ್ಟ್ ವೋಲ್ಟೇಜ್. ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಚೇಂಜ್ ಇಟ್ ಟು ಅಸ್ EMF per turn multiply by turn will give you EMF. EMF per turn ಅಂದ್ರೆ E divided by T ಬರುತ್ತೆ. ಅದಕ್ಕೆ ಮತ್ತೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ಟರ್ನ್ಸ್ಗೆ ಏನಾಗುತ್ತೆ? ಟರ್ನ್ಸ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಕ್ಯಾನ್ಸಲ್ ಆಗ್ಬಿಟ್ಟು ಫೈನಲಿ ಏನು ಉಳ್ಕೊಳುತ್ತೆ? EMF ಉಳ್ಕೊಳುತ್ತೆ. So that is a technique what I've written this EP in a different way. That is a multiplication of EMF per turn multiplied by turns. Okay, now did you get it? From the first formula concentrate ಮಾಡಿ ಕೊಟ್ಟಿರೋದ್ರಲ್ಲಿ ಅದರಲ್ಲಿ ನಾನು EP ನ ಹೇಗ್ ಬರುತ್ತೆ ಅಂತ ನೋಡಿ. Did all of you understood till here? Teachers, did you understood? EP ನ ಯಾಕೆ ET ಇಂಟು TP ಬರ್ದ್ರಿ ಗೊತ್ತಾಯ್ತಾ? ಪ್ರೀ ರಿಕ್ವೆಸ್ಟ್ ಫಾರ್ಮುಲಾ ಬರ್ದಿದ್ದೀರಾ? Okay, fine. Then next step what we can do is this product. What do you mean by product of ಅಥವಾ ನೀವೇನು ಹೇಳಿ ಅಂದ್ರೆ ಇದು ಟರ್ನ್ಸ್. ಓಕೆ, ವಾಟ್ ಈಸ್ ದ ಯೂನಿಟ್ ಆಫ್ ಕರೆಂಟ್?
ಆಂಪಿಯರ್.
What is the unit of current? Amperes. ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಇದನ್ನ ಏನಂತ ಕರಿತೀವಿ? ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಅಲ್ಲಿ ಓದಿದ್ದೀರಾ? ಇದು ನಂಬರ್ ಆಫ್ ಟರ್ನ್ಸ್. ಸೊ ಇದು ಆಂಪಿಯರ್ಸ್. ಪ್ರಾಡಕ್ಟ್ ಆಫ್, ಕ್ಯಾನ್ ವಿ ಕಾಲ್ ಇಟ್ ಅಸ್ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಆಂಪಿಯರ್ ಟರ್ನ್ಸ್. ಸೊ ಇವಾಗ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ಏನಿರುತ್ತೆ ಅಂದ್ರೆ ET ನ ಇಲ್ಲಿಗೆ ಇವನಿಗೆ ಏನ್ ಮಾಡ್ಬಿಡ್ತೀವಿ? ಡೈವರ್ಸ್ ಕೊಟ್ಬಿಡ್ತೀವಿ. ಆಯ್ತಾ? ಸೊ ಇದು ಇಲ್ಲಿ ಕ್ಲೋಸ್ ಆಗ್ಬಿಟ್ಟು TP ಮತ್ತೆ IP ನ ಜೊತೆಲಿ ಇಟ್ಕೊಂತೀವಿ. ಸೊ ದಿಸ್ ವಿಲ್ ಬಿಕಮ್ ಆಂಪಿಯರ್ ಟರ್ನ್ಸ್. AT ಆಂಪಿಯರ್ ಟರ್ನ್ಸ್. ಆಂಪಿಯರ್ ಯಾಕೆ ಬಂತು ಅಂದ್ರೆ ಕರೆಂಟ್ ಇನ್ ಯೂನಿಟ್ ಆಂಪಿಯರು. TP ಏನಂತ ಅಂದ್ರೆ ಅದು ಟರ್ನ್ಸ್, ಅದಕ್ಕೆ ಅದು T ಅಂತ ಡಿನೋಟ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಓಕೆ, ಇದು ಯಾಕೆ ನಾವು AT ತಗೊಂಡಿದ್ದೀವಿ? Somebody will ask, why ma'am we have not taken AP into TP? We have taken the ampere turns for both primary and secondary as equal. Okay, ampere turns of both primary. ಇದರಲ್ಲಿ ಎಷ್ಟು ನೀವು ಟರ್ನ್ಸ್ ಸುತ್ತಿದ್ದೀರಾ ಪ್ರೈಮರಿದಲ್ಲಿ, ಸೇಮ್ ನಂಬರ್ ಆಫ್ ಟರ್ನ್ಸ್ we are going to provide for the secondary. So therefore the product of ampere turns will be equal, which will be equated as ampere into turns. ಅಷ್ಟೇ. ಇದು ಜನರಲ್ ಆಗಿ ನಾವೆರಡಕ್ಕೂ ಸೇಮ್ ಇದೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಇದು ಆಂಪಿಯರ್ ಟರ್ನ್ಸ್ ಜನರಲ್ ಆಗಿ ಬರ್ತಿದೀವಿ. ಸಫಿಕ್ಸ್ ಏನು ಬರ್ತಿಲ್ಲ. ಆಯ್ತಾ? ಸಿನ್ಸ್ ಬೋತ್ ಆರ್ ಆಂಪಿಯರ್ ಟರ್ನ್ಸ್ ಆಫ್ ಪ್ರೈಮರಿ ಅಂಡ್ ಸೆಕೆಂಡರಿ ಆರ್ ಈಕ್ವಲ್, ಅದಕ್ಕೆ ನಾವು ಇದನ್ನ AT ಅಂತ ತಗೊಂತೀವಿ. ಓಕೆನಾ? ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. ಇವಾಗ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಏನಪ್ಪಾ ಅಂದ್ರೆ ಇವಾಗ ಯು ನೀಡ್ ಟು ಫೈಂಡ್ ಔಟ್ ವಾಟ್ ಈಸ್ ಆಂಪಿಯರ್ ಟರ್ನ್ಸ್. ಹೌ ಟು ಫೈಂಡ್ ಔಟ್ ಆಂಪಿಯರ್ ಟರ್ನ್ಸ್? ಸೊ ಫಾರ್ ದಟ್ ಯು ನೀಡ್ ಟು ರೆಫರ್ ದಿ ಪ್ರೀವಿಯಸ್ ಫಾರ್ಮುಲಾ. ಓಕೆ, ಇವಾಗ ಯಾವ ಫಾರ್ಮುಲಾ ರೆಫರ್ ಮಾಡೋಣ ಅಂದ್ರೆ ವಾಟ್ ಈಸ್ ನಿಮಗೆ ಪ್ರೀವಿಯಸ್ ಇದರಲ್ಲಿ ಆಂಪಿಯರ್ ಟರ್ನ್ಸ್ ಆಯ್ತಲ್ಲ, ಇವಾಗ ನಿಮ್ದು ಇದು ಟಾಸ್ಕ್ ಆಂಪಿಯರ್ ಟರ್ನ್ಸ್ ಹೆಂಗ್ ಕಂಡುಹಿಡಿಬೇಕು ಅಂತ. ಓಕೆ, ಫೈನ್. Yeah. As I told you, product of TP into IP is equal to TS into IS, which is generally taken as AT. Okay, fine. So ಇವಾಗ AT ಕಂಡುಹಿಡಿಬೇಕು. AT, if you want, you should know the formula for AC. What is AC? Then what is KW? ಆಯ್ತಾ, AT ಆಂಪಿಯರ್ ಟರ್ನ್ಸ್ ನ ಸಾಲ್ವ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಯು ಶುಡ್ ನೋ ದ ಫಾರ್ಮುಲಾ ಫಾರ್ AC, ಏರಿಯಾ ಆಫ್ ಅ ಕಂಡಕ್ಟರ್. ಆಯ್ತಾ, ಆಮೇಲೆ ವಿಂಡೋ ಸ್ಪೇಸ್ ಫ್ಯಾಕ್ಟರ್, ಅದೇ ಸ್ಪೆಷಲ್ ಟು ಫಾರ್ಮುಲಾಸ್ ಬರ್ತಿದೀವಲ್ಲ ಅಡಿಷನಲ್ ಆಗಿ ಪ್ರೀ ರಿಕ್ವೆಸ್ಟ್ ಫಾರ್ಮುಲಾದಲ್ಲಿ, ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ಯುಟಿಲೈಸ್. ಆಯ್ತಾ, AC ಅಂದ್ರೆ ಏರಿಯಾ ಆಫ್ ಅ ಕಂಡಕ್ಟರ್. ಏರಿಯಾ ಆಫ್ ಅ ಕಂಡಕ್ಟರ್ ಅಂದ್ರೆ ನೀನ್ ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಟರ್ನ್ಸ್ ನ ಸುತ್ತಿದೆಯಾ ಪ್ರೈಮರಿಗೆ ಸೆಕೆಂಡ್ರಿಗೆ ಅದು. ಆಯ್ತಾ, ವಿಂಡೋ ಸ್ಪೇಸ್ ಫ್ಯಾಕ್ಟರ್ ಅಂದ್ರೆ ಇಟ್ ಈಸ್ ಅ ರೇಷಿಯೋ ಆಫ್ AC ಡಿವೈಡೆಡ್ ಬೈ AW. ಕ್ಲಾಸ್ ವರ್ಕ್ ಅಂತ ನಾವು ಕಟ್ಕೊಳ್ಳಿ, ಇದು ಸಿ ಮೇಲೆ ಬರುತ್ತೆ, ವರ್ಕ್ ಕೆಳಗಡೆ ಬರುತ್ತೆ ಅಷ್ಟೇ. ಆಯ್ತಾ, ಸೊ ನಾಟ್ ಅ ಪ್ರಾಡಕ್ಟ್, ಇಟ್ಸ್ ಅ ರೇಷಿಯೋ. ವಿಂಡೋ ಸ್ಪೇಸ್ ಫ್ಯಾಕ್ಟರ್ ಕ್ಯಾನ್ ಬಿ ಡಿಫೈನ್ಡ್ as AC by AW. ಇಷ್ಟೇ, ಇದೆರಡು ಬೇಸಿಕ್ ಇಟ್ಕೊಂಡು ಆಂಪಿಯರ್ ಟರ್ಮ್ಸ್ ಯು ಕ್ಯಾನ್ ಸಾಲ್ವ್. ಹೌ, ಐಲ್ ಟೆಲ್ ಯು. Now, as I told you, AC generally it talks about the how much ampere turns you have provided. Okay, now. So, ಇವಾಗ ampere turns ಬಂದ್ಬಿಟ್ಟು primary also you have to take. You have to consider for primary also. You need to consider for secondary also. So, when you write, it is TP into IP. Sorry, TP into AP. ಹಿಂಗ್ ಬರುತ್ತೆ, ಒಂದು ನಿಮಿಷ. ಹಾ, AC can be written as product of TP into AP plus TS into AS. Okay na? AP andre ಏನು? It is the area of primary winding. AS andre area of secondary winding. ಆಯ್ತಾ? So, do you know the formula for current density? Current density, ಮತ್ತೆ refer prerequisite formula. Current density can be defined as current divided by area. Current density can be defined as current divided by area. Okay, now. So, how do you define area? Area can be written as, check in your prerequisite, area can be written as current divided by current density. Area can be written as current divided by, area can be written as current divided by current density. Okay, now. So, what you will do is, you can see that here, one more note, this TP into AP plus TS into AS. Before that, you can just see in your single phase transformer, usually the window in a single phase transformer will contain one primary ಮತ್ತೆ one secondary winding. ಒಂದು primary ಇರುತ್ತೆ ಮತ್ತೆ ಒಂದು secondary winding ಇರುತ್ತೆ. So due to that reason, what we will do here is, we will just multiply by 1 only. 1 times of primary ampere turns plus 1 times of secondary ampere turns. So ಅದಕ್ಕೆ ಇಲ್ಲಿ ಯಾವುದೋ ನಿಮ್ದು ಮಲ್ಟಿಪ್ಲೈಯಿಂಗ್ ಫ್ಯಾಕ್ಟರ್ ಬರೋದಿಲ್ಲ. But in case of 3 phase you will get. But in case of single phase, there is no parameter is getting multiplied. It is multiplied entirely by unity 1, because there is only one primary winding in a window and one secondary winding in a window in case of single phase transformer. Adil ತೋರಿಸ್ಬಿಡ್ತೀನಿ diagram. Where is that diagram? Yeah, one primary winding in one window, one secondary winding in one single window. ಇದರಲ್ಲೂ ಅಷ್ಟೇ 2 windows ಇರುತ್ತೆ. one windowದಲ್ಲಿ ಒಂದು primary ಇರುತ್ತೆ ಮತ್ತೆ ಒಂದು secondary ಇರುತ್ತೆ. So in that criteria, for a single phase, you can say that one window of a single phase transformer will contain one primary and one secondary winding. So that is why this parameter is obtained by multiplying by 1. So AC can be written as product of ampere turns for both primary as well as secondary. Current is again replaced by current divided by current density. ಇದು ಯಾವ್ದ್ರದ್ದು? ಪ್ರೈಮರಿ ಡಿವೈಡೆಡ್ ಬೈ ಡೆಲ್ಟಾ. ಕರೆಂಟ್ ಡೆನ್ಸಿಟಿ ಒಂದೇ ಇರುತ್ತೆ. ಓಕೆ, ಸಿಮಿಲರ್ಲಿ AS is equal to current of secondary divided by current density. This is again a prerequisite formula. Okay, so after when you substitute this, AP will be substituted here as IP divided by delta. AS will be substituted as IS divided by delta. How does it looks? It looks as AC is equal to TP into IP by delta plus TS into IS divided by delta. So Now again you will find delta is common factor. So you can just write in this way. Okay, Tp into Ip plus Ts into Is divided by delta. So generally what we took, ampere turns of primary is same as that of ampere turns of secondary, which is taken as ampere into turns. So we have written it will be equal, no? So when it is equal, it becomes 2 times. Both are equal. So we can take it as 2 times. Okay, now fine. So it is 2 times of AT divided by delta. So we will keep it this as equation, one equation. Again, now we are intention to find out what is the formula for ampere turns. Still, we have not obtained. Here, you can see that only ampere turns value can be written as AC into delta divided by 2. But again, you don't know what is AC. To know that AC, we should know the KW formula. What is KW? AC by AW. Window space factor is AC by AW. So therefore, AC is equal to KW into AW. Then you need to equate these two. LHS is same, only the RHS is different. So therefore, when you equate these two, so you'll get ampere turns. So ampere turns when you solve, you'll get it as KW into AW into delta divided by 2 after equating equation number 2 and 3. So this is how you can find out the ampere turns in the output equation. Getting? So this is what we got the ampere turns. So this will be the thing after equating equation 2 and 3, you will get this. Okay, then finally you simplify this further. What is ET formula you have written? ET, EMF per turn in the prerequisite formula 4.44 F into psi m. F 4.44 F into psi m. Okay, so finally you just simplify further, you will get come to a 2.22 F into psi m into KW, AW into delta into 10 power of minus 3. If you want, you can end up your formula till here. Otherwise, you can just simplify this flux as flux density multiplied by area. Flux can be written as flux density multiplied by area. So that is dm into ai. So this will be your final equation. Understood? Shall I give time to write in your notebook? Shall I give time? Okay. Now you can just start to write. Yeah, you can start to write. By the time I'll take attendance. When you're finished, I'll go to next slide. You can copy that time. You have to tell me. Okay? Fine. By the time you answer the attendance. Kartik absent. Santosh present. Maulika.
Present, ma'am.
Present. Nagajyoti present. Rukmini present. Rakshita present. Sachin.
Ma'am, Rakshita present, ma'am. Mic was not working, ma'am. So
ಹಾಕೊಂಡಿದ್ದೀನಿ ಪ್ರೆಸೆಂಟ್ ಹಾಕಿದ್ದೀನಪ್ಪ. ಸಹಾನಾ ಪ್ರೆಸೆಂಟ್. ಸುಜಾತಾ ಪ್ರೆಸೆಂಟ್. ತೇಜಸ್ ಪ್ರೆಸೆಂಟ್. ತನುಶ್ರೀ ಪ್ರೆಸೆಂಟ್. ಸಾತ್ವಿಕ್ ಇಲ್ಲ. ಸಾತ್ವಿಕ್. Okay. Dattatreya. It's not there. Dattatreya is not there. Rashmi or then Yashoda. Yashoda is present. Okay. Completed. Shall I move on to the next slide?
Yeah, ma'am.
No, ma'am. Yes, ma'am. Done.
Take down. Next. The voltage induced in a transformer winding with T turns, capital T turns, and excited by a source having a frequency F hertz is given by voltage per turn, that is ET, E small t, ET is equal to E divided by T, ET which is equal to capital E divided by T, which is equal to 4.44 F into psi m. 4.44 F into psi m. Equation number 1. Equation number 1. Below that, the window in a single phase transformer contains one primary and one secondary winding. The window in a single phase transformer contains one primary and one secondary winding. One primary and one secondary winding. Done. Shall I go next slide? Next slide.
Yes, ma'am.
Yes, ma'am.
Okay. Take down. Therefore, total copper area in a window. Total copper area in a window. That is AC. AC is given by copper area of a primary winding plus copper area of a secondary winding. Copper area of a primary winding plus copper area of a secondary winding. Again, that is equal to product of primary turns, product of primary turns and area of primary conductor. Adu copper area of primary winding. Copper area TA. Okay, make sure that here it comes Tata. Okay, AC is equal to TA. ಮತ್ತೆ ಟಾಟಾ ಆದ್ಮೇಲೆ ಬೈ ಬೈ ಅನ್ಬೇಡಿ, TA ಬರಬೇಕು. ಓಕೆ, ಪ್ರೈಮರಿ TP ಪ್ಲಸ್ ಸೆಕೆಂಡರಿ TS. Okay, remember this whenever you derive for AC. They should be the product of T into A. ಆಯ್ತಾ, ಇದು ಎರಡು ಪ್ರೈಮರಿನು ತಗೋಬೇಕು, ಸೆಕೆಂಡರಿನು ತಗೋಬೇಕು. ಸೊ ಇದನ್ನ ರಿಮೆಂಬರ್, ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್ ದಿಸ್ ಡಾಟಾ. ಓಕೆ, ನೆಕ್ಸ್ಟ್, ವಾಟ್ ಈಸ್ ಎಪಿ? AP is current divided by IP divided by delta. Take down. AS is IS divided by delta. Done. Delta is current density. Delta andre current density. Next slide. Therefore, total conductor area in a window, andre when you substitute that area AP matte AS, this is a change. What you will find? Take it down fast. After substituting AP and AS, it results with this formula. Delta is a common factor at the denominator. The numerator, both you will treat it as equal, so which is equal to A into T. Equation number 2, AC. Equation number 2. Again, to find this AC, one more formula we are going to use, that is window space factor. Equation number 2 aita. Next, window space factor KW is defined as conductor AC divided by AW. Okay, remember that classwork code, AC divided by AW. AC andre conductor area in a window. AW means total area of a window. Okay, from this you cross multiply what is AC. So AC, to find AT, we are using AC and KW formula. Okay, so to get this AC, again it is a product of KW into AW. So that is equation number 3. So after equating equation 2 and 3, LHS is same. AC ide, illu AC ide. You have to worry only about RHS. RHS na equate madi. When you equate the RHS, you should get the A into T formula. ಆಯ್ತಾ ಇದು? ಈ ಸ್ಲೈಡ್ ಮುಗಿತಾ? This is how we obtain the ampere turns finally. So we get ampere turns is equal to KW AW into delta divided by 2. Over. Last slide. Shall I move to the last? Over.
Yes, ma'am.
Yes, ma'am.
Yes, this is the last slide. Rating of a single phase transformer in kVA is given by Q, which is equal to, as I told you, it's a product of V into I. Vp into Ip into 10 power of minus 3. Vp na same as that of Ep. Ideal transformer ge gottala. Voltage Vp is equal to same as that of Ep. So adanna barಕೊಳ್ಳಿ. Ep into Ip into 10 power of minus 3. ಇಲ್ಲಿ separate ಮಾಡ್ತೀವಿ. Ep na is split up into product of Et into Tp. ಮತ್ತೆ ಅದಾದ್ಮೇಲೆ ಇದನ್ನ ಸ್ಪ್ಲಿಟ್ ಅಪ್ ಮಾಡ್ತೀವಿ. Tp ಮತ್ತೆ Ip ನ we will consider as ampere turns. ಮತ್ತೆ At ನ refer back to your notebook. In the previous slide I have derived what is At. Equation number 4. Equation number 4 ಅಲ್ಲಿ ಏನ್ ಬರ್ಕೊಂಡ್ರಿ? At is nothing but we got KW AW delta divided by 2. What is Et? ಇದು ಬಂದ್ಬಿಟ್ಟು equation number 1. Equation number 1 ಅಲ್ಲಿ Et ಏನಿತ್ತು? 4.44 F into psi m. Substitute ಮಾಡಿ, simplify further. Till here you will stop. Then what is again flux? Flux can be defined as product of flux density into area, Bm into Ai. ಅಷ್ಟೇ. So this completes the output equation of single phase transformer. In next class, I will discuss about the output equation of 3-phase transformer. Okay, I'll share the recording of this class. To your mail ID.
Okay,
If
ma'am.
any problem is there with the access, please ask me. Okay. Today only I'll share it off. Now itself. Done till here.
Done, ma'am.
Done? Okay. See here, based on this, what is the question they will ask in V2 is derive the output equation of a single phase core type transformer. Then, if they ask you the question as derive the formula, output equation for a single phase core type. Okay. So core type go ಇದೆ ಫಾರ್ಮುಲಾ ಶೆಲ್ ಟೈಪ್ಗೂ ಇದೇ ಫಾರ್ಮುಲಾ ನಪ್ಕಟ್ಕೊಳ್ಳಿ ಕೋರ್ ಟೈಪ್ಗೂ ಸೇಮ್ ಫಾರ್ಮುಲಾ ಶೆಲ್ ಟೈಪ್ಗೂ ಇದೇ ಫಾರ್ಮುಲಾ ಇಫ್ ದಿ ಟ್ವಿಸ್ಟ್ ದ ಕ್ವೆಶನ್ ಇನ್ ದಿಸ್ ವೇ ಬೋತ್ ಫಾರ್ ಅ ಸಿಂಗಲ್ ಫೇಸ್ ಅಂದ್ರೆ ಇದೆ ಇಷ್ಟೇ 2.22 ಪ್ಯಾರಾಮೀಟರ್ ಇರಬೇಕು ಎಫ್ ಇಂಟು ಬಿ ಎಂ ಇಂಟು ಎ ಐ ಇಂಟು ಕೆ ಡಬ್ಲ್ಯೂ ಎ ಡಬ್ಲ್ಯೂ ಇಂಟು ಡೆಲ್ಟಾ ಇಂಟು 10⁻³ ಅಷ್ಟೇ okay. So from today's class what you did, we had discussed the basic formulas for the EMF equation. Then today you learned what is EMF per turn. Okay. Then what is the new parameter which you learned? Window space factor. But AC current density. Go to the current density. Then what is the new formula which you have gone through? Which is the new formula? Flux density no ಗೊತ್ತಿದೆ ಆಯ್ತಾ ದ ಫಾರ್ಮುಲಾ ರಿಲೇಟೆಡ್ ವಿತ್ ಎ ಸಿ ಅಂದ್ರೆ ಏನು ಓಕೆ ದಟ್ ಈಸ್ ವಾಟ್ ವಿ ಡಿಸ್ಕಸ್ಡ್ ಟೋಟಲ್ ಕಾಪರ್ ಏರಿಯಾ ಆಫ್ ದ ವೈಂಡಿಂಗ್ ದಟ್ ಈಸ್ TA ಟಾಟಾ ಅಂತ ಹೇಳಿದ್ನಲ್ಲ ಅದು ದಟ್ ಈಸ್ TA AC we discussed and this and all you already know aware of it in the lower semester ಇದು ಗೊತ್ತು ಇದು ಗೊತ್ತಿದೆ only these two special and this one 3 formulas okay but then from today onwards you remember for primary we will have a suffix as p not 1 for secondary ಏನು ಯೂಸ್ ಮಾಡ್ತೀರಾ yes okay TS not no N2 like that okay fine. Have you all understood the output equation? Okay, today you go through it. Tomorrow, Monday, if you have class, as per the timetable. So Monday we will discuss once again. Okay, thank you all. You can just continue with you have a microcontroller class. Okay, thank you.